I'm starting the recording now. Assalamu alaikum everyone and good afternoon. Our class for today is an online demonstration session for experiment number 3, objects in equilibrium. We are going to study, you can open your lab manual to this page. Let's give it a time. Okay, that's the page. Okay, page number 37 in my PDF. If you want this PDF, by the way, I can send it to you in Blackboard. Okay, so this one is our experiment for today. Now, what are we going to study here is number 1, an example of what we call an object under static equilibrium. And using the idea of objects in equilibrium, we are going to find the magnitude of an unknown mass in the given system, which is in the equilibrium system. Okay, so if you look at it, there are 2 objectives to this experiment. Now, the apparatus, it is given in the list. Excuse me, you will see it in the video. Let's talk about the theory. In the theory, well, in physics, quantities are categorized or divided into 2. The first one is scalar quantity, and the second is vector quantity. And the difference between them is simple. A scalar quantity is a quantity that has only magnitude, no direction. Only magnitude means just a number. For example, 5 kilogram, okay? Or more accurately, let's take my weight, in this case, my mass, 65 kilogram. When does it become a vector quantity? So it becomes a vector quantity when you have magnitude and direction. In this case, if you take 65 kilogram, multiply by 9.8, which is acceleration due to gravity, meter per second squared, this value becomes weight. Okay, let's use the value 10, so it becomes 650 newtons. And the direction of weight is downward. In this case, it becomes a vector quantity. And what makes this important is that when we are, let's say, adding a vector quantity as opposed to a scalar quantity, the difference is that when you add vector quantity, you have to add both the magnitude as well as the direction. Okay, and it gives a different result when it comes to the it gives a different number when it comes to the result. For example, if you have simply 1 plus 1, that's equal to 2. That's a scalar addition. But vector addition is different. If you have 1 going to the right, okay, plus 1 going to the left, because they are equal but opposite, this will translate into 1 plus negative 1 equals 0. So you see the difference is that the direction of a vector quantity will affect the final result. Okay, so today what we will do is, first we will have an object which is in static equilibrium, a system actually made up of 3 different objects, and then we are going to find the unknown mass using what we call the first condition of equilibrium. What's the first condition of equilibrium? Simple. If an object or a set of objects, that means a system, is in translational equilibrium, or simply saying mechanical equilibrium, okay, the net force, the total force acting on it must be 0. Therefore, if you take all the forces in the x-axis, y-axis, and even z for a 3-dimensional system, the total will always be 0. Therefore, let's say that we have 3 numbers which is in equilibrium. Let's keep it as numbers, okay? If you say 2 plus, let's say to the right, okay, plus 2 to the left, plus 2 again to the right, what is the total? Sorry, I made a mistake in adding. 2 to the right plus 2 to the left plus x. I'm sorry. Let's do it again, okay? 2 to the right, 1 to the left, plus x equals 0. There you go, okay? This is in equilibrium because the total forces in the x-axis is equal to 0. What's the value of x? That's the idea of today's experiment. By taking all the three values, knowing that it's equal to 0, we can find the unknown value. And we will use three different methods today. Okay? What are those three methods? The first one is by graphical method. The second one is by mathematical method, using a given equation. And the third is by analytical method, which is breaking down the x and y component of each vector and then finding the total. Okay, so let's start with the graphical method. I'm going to show you first how or which values we are going to make by showing you a video, the same video which I sent you in the link. Okay, and these values, we are going to enter them in the data sheet. So prepare your data sheet like this, using the one in the lab manual. I'm going to play the video now. Hello. Today we are going to study the concept objects in equilibrium, and we are going to use this concept to find the value of an unknown mass, which I have in my hand. Okay, that's the unknown mass. That's the third value. But we will use two values left and right here to find the third one, okay? Using three different methods of adding vector quantities. First, let me introduce you to our equipment. We have a magnetic board. Attached to it by magnets are two pulleys right here on top. And over the pulleys, you will find a string that passes through, or over the pulley. At each end of the string, you will find mass hangers. In the center of the magnetic board, you will find a degree scale. Of course, we have our unknown mass. And finally, we have a set of masses for which we are going to use defined or known values of mass. How are we going to set up the experiment? First, you have to know how to open the mass container on the box for the masses. Pinch or press at this part of the box and lift the cover. Next, if you have a digital balance in the lab, use the digital balance to measure the real or the true value of this object's mass and record it in your data sheet here. Next, you take known values of masses and you are going to use it to balance the unknown mass in our system. Here's how you do it. I recommend the value of 75 grams for each of the masses or mass hangers. That would be 50 gram mass plus 20 gram mass plus the hanger itself is actually equal to 5 gram. Combine them together and that's 75 grams. Hold this in place because if you let it go, this will fall. What you do is you take the other 70 gram mass and hang it in the opposite side of your board. There you go. You have to make sure that the string is passing over the pulley and not behind it. Okay? Once that is done, make sure that these masses are not because they will cause you errors in your reading. Okay, can you hear me? Let me pause the video. The two things that's mentioned in the video, what are those two things? Number one, the string must be over the pulley. And number two, the hangers should be steady. Steady means not swinging, not moving, okay? What are those two things? Those two things are what we call source of error or precaution, okay? Yes, Ryan, your question? You can speak in your microphone, please.
Teacher,
Go ahead.
I have a problem with
Just tell us, what is it?
I left and I come.
You what?
I left and I come back.
So there's no problem. You left and you come back. That's it.
No problem in my.
No problem. As long as you come back. If you left without coming back, then you have a problem. Clear?
Thank you.
Okay. Let's continue. So in the lab manual, you have to write it. Don't worry. At the end, I will remind you, okay? Which part of the lab manual you have to write it? Here. Source of error and precaution. So for you, let's type it now so that you will, so that we will not remember it. What's the precaution? The string must go over the pulley. So, what else is a precaution? The masses must be steady. What does it mean must be steady? They should not be moving. Is that clear? So you will write this in your report as well. Allah, so easy. I'm making the report for you. Let's continue with our video. Next, take the unknown mass and make sure you already recorded the value according to your digital balance. If the digital balance or the triple beam balance is not available, you can also ask your teacher for some assistance. Okay, once you hang the unknown mass,
Doctor, we can't hear you.
I'm sorry, the mute is going on and off, maybe by spacebar. So again, this mass, okay, is equal to the unknown mass, and the real value is measured by digital balance. Usually we get 104, 105, or 106 grams, depend on the object, okay? Because, you know, if the object you make it drop, sometimes it will lose a small piece of mass, so the mass changes. So for us, everybody will use 105 gram weight, okay? Is that clear, Shabab? The real value that we will use is 105 gram weight, okay? Let's continue. As in the middle, make sure that it's not touching the table. If it is, you can take the string and tie it so it will be shorter. Let all three objects hang freely. What happens here is now, each object has a mass, that's your mass 1, mass 2, and unknown mass, and multiplied by gravity, each of these mass becomes weight. The direction of the weight is, of course, downwards. Mass 1 is downward, that's the force of the weight. Mass 2, direction with the gravity is downwards, and the unknown mass with gravity has a weight that is also downwards. But if you notice, none of these three objects are falling. That's because the total sum of all the forces or all the weight is actually equal to 0. That is what we call an object or a set of objects that are in equilibrium. Okay, just to push the point that because none of this object is moving, they are steady, like a traffic light hanging, for example, okay, or like a chandelier that's hanging in your house, it's not falling. That's because the total forces that's applied in the system equals 0. That's the objects in equilibrium. In this case, what we will do is we will take mass 1 plus mass 2 plus mass 3, the unknown mass, equals 0 by using vector addition. The total forces, weight of 1 plus weight of 2 plus the unknown weight is equal to 0. And that's how we will find the value of the unknown weight. The three methods we are going to use are by graphing, mathematical equation, and using an analytical equation. So let's begin. Okay, so I don't know how this video will be. Okay, let's continue watching. First, you have to record the values of mass 1 and mass 2. And because we are talking about vectors, we will record them as tension. What is tension? That's the force that's being applied on a string. Remember that a string connects all the three masses together, and that mass 1 with gravity, that's weight number 1, applies a tension on the string here in the direction downward. But because the string goes over the pulley, the direction for tension of mass 1 is actually changed. So instead of downwards, it becomes at an angle. The same is true for mass 2 with gravity becomes weight 2, and that weight pulls the string, giving it tension. The direction of tension number 2 from the center is going up at this angle. And finally, we are sure that the tension for the unknown weight is actually downward because it is simply in the direction of gravity. In order to measure the tension, we will simply take what we call the mass weight value of each masses. If this is 75 gram weight, that will be the value of T1, 75. If this is 75 gram weight as a mass weight, that would be equal to 75 as T2. Finally, we need to measure the angles of T1 and T2 and record it in our lab manual or data sheet here. In order to measure the angle correctly, you have to make sure that the string, the center of the string where the three objects are attached, is in the center of the degree scale. So how do you do that? You can move the degree scale across the board, but make sure that the center of the string here is in the center of the degree scale. So place the degree scale gently behind the string. Another thing that you need to measure is actually, or to make sure, is actually the string of the unknown mass. It must be straight down. And what angle is that? 270 degrees. So you have to rotate your degree scale to make sure that string number 3 for the unknown mass is at 270 degrees. The best way to do it is by standing in front of the board and looking at it straight or directly. There you go. Test, mic, test. Okay. This is now the setting that we are going to use for the angles. Okay. If you can look at the angle of T1, how much should be theta 1? Here. How much should be theta 1? I'm pointing at it with my mouse. This is the string of T1. Anyone? 46 degrees. Okay, not 54, not 47. Looking at it straight, this is 40. This is 45. One line after 45 is 46. Okay, so we will use 46 degrees here. You have to write it in your book. I'm going to write it later in the PDF copy. What about T2? This is T2. Okay, what is the angle of T2 from 0? 138. So we will use 46 and 138. Clear? So if you want, from 0, theta 2 is the angle that T2 or tension 2 makes also from 0. That is in the second quadrant. Okay, by watching the video, trust me, the link that I sent you, you will understand it again if you miss anything. Also, you can always ask questions. Now let's continue. Yes, Mohammed, what's your question? If you're asking, are we in a group? No, we are in a full section. There's no group when it's online. Can we continue? Okay, let's continue. So how do we, let's watch the video. Graphical Method. What's going to happen. This is how you do it. The first thing. Okay, there's a graph which is in the YouTube video as well, but I want to do the graph in front of you. Okay, so I'm gonna switch to my camera. Just give me a few seconds for the setup so I can make the graph. But first, let's write down the values. We know that, okay, T1 and T2 is 75 gram, 75 gram. We know that theta 1 is 46 degrees and theta 2 is 138 degrees. Clear? What does it mean corresponding length? Because the unit is gram weight or grams, we cannot graph. There is no mastara. You will not find mastara. Salem. Again, guys, I'm telling you, I will give you a link to a Telegram group. If you want to keep a WhatsApp group, fine, but I will not join the WhatsApp group, okay? Mastara, you will not find it in gram or in gram or kilogram. You'll find it in centimeter or millimeter or inches. So you have to change from gram to centi. If we make 1 gram equals 1 centi, then the graph will be 75 centimeters long. Again, another problem. This is only 22 centi. 75 centi means almost 1 meter, okay? Because 1 meter is 100 centi. So you have to make the scale lower. 10 gram, again, 10 gram equals 1 centi will give you a scale or corresponding length of 7.5, okay? So 10 gram, 1 centi becomes 7.5. 7.5. Do you understand? 75 divided by 10, 7.5. 75 divided by 10, 7.5. That's the corresponding length. Any questions about this table? Any questions about this table, guys? Come on. Yes, Abdulaziz, what's your question? I want to make sure that everything is clear before we continue. What's your question, Abdulaziz? While I set up my camera, can you reply? Okay, which part? From the beginning? No. Which part do you want to see? Tell me. You want me to repeat which part, Shabab? The last part. How did I get 7.5? Is that your question? Okay. So how I got 7.5, I want you to look, is this, okay? First, we need to make a scale of 10 is to 1. Why 10 is to 1? Because this number is too big and it's also in gram. We want it to be smaller and also in centi. Is that clear? That's why we choose 10 is to 1. But then what do? We divide 75, divide by 10, become 7.5. 75 divided by 10 become 7.5. Is that clear? Is that clear now? Hello? If you ask questions, I need to know if it's clear now. Okay, good. Good. Now, I'm going to change. I'm going to show you another screen, okay? 1 second. What do we have? Because I need to see that it's clear for everybody. Okay, I think that's about clear. Then I'm going to, 1 second, guys, 1 second. I have to project this. Excuse me, guys, I have a call. 1 and theta 2, we can now... Sagutin mo ba? Sorry, because somebody called me. I hate this mic on and off. Okay, again, I will show you the video how to make the graph. Where is it? Where is it? And then we will do the graph again in real time using a second camera. Clear? So I want you to watch the video first. Is the scaling, because we actually cannot graph grams on paper. So instead, we have to scale our gram. We will convert it into centimeter. Now, this kind of conversion is not an actual conversion of unit, but what we call scaling. And we will use the values for every 10 gram, we will graph it as 1 centimeter. Now, if you remember, T1 and T2 are both 75 grams, so they will become 75 grams divided by 10 becomes 7.5 centimeter. On the paper, we will start by determining our X and Y axis. So take your straight edge or your ruler and your pencil, and then just follow the grid or the lines on the paper by identifying first our X-axis. Draw the X-axis on the lines of the paper. Okay, that's our X-axis right over here. Let's label it as X-axis. And then at the center, just make some estimation. You can draw your Y-axis, which is 90 degrees with the X-axis. Always remember that when you draw your lines, you have to keep most of the graph on the first and the second quadrant, because the third and the fourth quadrant here, this is the third quadrant and this is the fourth quadrant, we are not drawing anything. So keep this at the bottom of your paper. Okay. Next, using a degree scale, which is this one, you have to measure the angles T1 and T2 make with 0. So this is the 0 or the x-axis. Make sure it's aligned. And this is the 90-degree angle. Make sure it's aligned with the y-axis. And from there, just find or determine the angle of theta 1, which is the angle T1 makes with 0. So that's 41 degrees. This is 0, 10, 20, 30, 40. This line 40 is from here also. So that is 40. And this is 41 at the tip of my pencil. And keep the pencil in that place. Now we are going to draw T1. Starting from the point of origin here, you have to draw a line that is equal to, from the scale that we used, 7.5 centimeters. So remember that this is the angle where the pencil is now, theta 1, 41 degrees. This is the point of origin. T1 makes an angle that is 41 degrees. That's your theta 1. And how long should it be? 7.5 centimeters. So up to this point here. At the end of the line, put an arrow so that you have the direction of T1, and then label the graph T1. Now it's time to find T2. So we bring back our degree scale. And then we find the angle 138. So that's 90, 110, 20, 30. This is also 130. So that's 131, 32, 33, 34. This is 35, 36, 37, 38. At that point, you should mark with your pencil. Okay, you can move the degree scale away. And that's your 138. We know that T2 is equal to T1, 7.5 centimeters. So from the point of origin of your graph, place your ruler at 0. The straight edge of the ruler at the angle 138. Make the adjustment and then draw a line equivalent to the scale, which is 7.5 centimeters. At the end, draw a tip and label it T2. Now we have T1 and T2, the angle theta 1 and the angle theta 2. How much is theta 2? You can label it 138 degrees. How do we add these two lines? It's simple. Imagine cut and paste. We cut T1 and we move it at the end of T2. But because we are doing graph, we cannot simply cut the paper. So what we are going to do is we are going to transfer T2 using the exact measurements. What to do or how to do it is following these steps. First, using the line of T1, remember that the length is equal to 7.5 at the tip right over here from 0. Just extend this line there. Okay, we still know where T1 ends at this point. Once you've extended that line, what happens is that if you take T2 and you slide it while keeping the same angle, it forms an angle with T1 right over here, right? That angle is known as theta, and it's existing in the graph that we started in the beginning. It's the same angle as this, theta. Mathematically speaking, you can find it as theta 2, which is this angle, minus theta 1, which is this angle over here. There are two ways to find it, by calculator, and number 2, by measuring. So if we measure, place your 0 from the degree scale on T1, and then read what's the angle of T2. In this case, if we read from the degree scale from T1, T2 is, or theta, I should say, is at 90, 95, 96 degrees. So we can write theta equals 96 degrees. We now take our degree scale, the center of the degree scale, we place it at the end of T1, and of course T1 will be at 0, like this. And what you do is you measure 96 degrees from there. So 0, 90, 91, 92, 93, 94, 95, 96, and then you mark that point. That's 96 degrees. Okay? So basically what we did is we measured the angle between T1 and T2, that's theta, and then we transferred that angle theta here, which is 96 degrees. From that point, the end of T1, we will do what we call head to tail method. So the head of T1 will be attached to the tail of T2. That will be the measurement of your T2 from 0 centimeters up to the 96 degrees here, going to a length of 7.5 centimeters. Why 7.5? Because that's the length of T2. So which line is this now? This is now T2 prime, the reflection of T2. And if you look closely, the angle that T2 prime makes with the extension of T1, this one here, is the same as the angle here. How do you check if your graph is good? If I measure the end of T2 up to the head of T2 prime, what should be this length and what should be the angle? It should be the same as T1. 7.5. So let's try it. If we focus on T2 at the end, right over here, and place 0, look at the measurements. At the end of T2 prime is equivalent to 7.5 centimeters. You can close the graph if you like, or you can keep it open. Finally, what really happened here is we added the vector of T1 plus the vector value of T2, so that's T1 plus T2, to find what? We wanted to find, based on equilibrium, T1 plus T2 plus R is equal to, let me show it in the video right over there, T1 plus T2 plus R is equal to what? 0. Remember, objects in equilibrium, the sum of all forces is equal to 0. So where is 0 in the graph? It's here, at the bottom, here, right over there, right? That's where 0 is. So let me write again. T1 plus T2 plus R. Remember what R is? FR is equal to 0. That's the rule for equilibrium. So if we add T1 plus T2 plus the third value FR, let's call it FR, it's equal to 0. Where's 0? Right over here. So where do we draw the final line? To add T1 plus T2 plus FR to get 0, the final line is at the end of T2 prime going back to 0. That's the final line. And that line is R, or the resultant, which is the same as the mass of the unknown with the unknown value FR. Of course, we are measuring this FR in centimeters, which is equal to, from 0, wow, exactly 10 centimeters. Using the value of FR, we can now scale it back. Remember that this is our scale. Okay? If FR is equal to 10 centimeters, how much is it in gram? Of course, multiplied by 10, it becomes 100 grams. And that's how we find the value of FR using a graph. Finally, the direction of FR. It's easy. You can simply measure what we call alpha. That's the angle from T1, this is T1, going to R, that's alpha. Use your degree scale. From T1, what is the angle of FR? In this case, it's 40, I'd say it's 49 degrees. So alpha is equal to 49 degrees. And this is the final result of finding the resultant or the unknown mass, which is in equilibrium, okay, right over there, using the graphical method. Okay, Shabab, so that's how it's done. Now, if you want me to repeat, because there is one problem with the video, okay? The video was taken in two different setups, and what happened is that, let me show you. Did you see the mistake in this video, Shabab? Guys, did you see the mistake in this video? There is one small mistake here. The angle instead of 46 is actually 41. Okay? But in reading the angle from the setup is what? From here. If you remember the angle from here, 46. Okay? That's why it's better if we will repeat the video using real-time measurements. Any questions how to make the graph? You can ask while I make the video, okay? You will need a degree scale, mascara, graph paper. Now, if you want to use your own graph paper, the one which is not in the, what do you call this one? The one which is not in the lab manual, you can, okay? Again, if you want to use the one which is not in the lab manual, you can. Now, let me try. I'm trying to make this really full screen. This is my streaming software, by the way. Let's see. Project. I couldn't see the project because if I go live here, this will be projected in Twitch. Output projector. Where did it go? Where did it go? 1 second. Let me see. Nope, not that one. 1 second, guys. By the way, Rayan, your signal I notice is a little bit bad, isn't it? It's coming in and out. Are you using data or also Saud? Maybe I should check the attendance now. Where should I project this one? It's not showing. There you go. There. Okay. Now it's full screen, finally. Okay, let's make a graph. So first, you have to draw. Can you see my graph? Right? Shabab, can you see it?
Yes,
Can
we
you see?
can.
Okay, okay. First, you have to draw a horizontal line for your x-axis. Okay? So that's your x-axis. Make sure that you're going with the line of the paper. Okay? I'm working around the camera, so it's a little bit difficult for me, but you should be able to do it. And then make a y-axis. Okay? So x-axis and the y-axis. Now, what you notice is that the x and y-axis should be a little bit lower. It should be a little bit lower. Why? Because the graph will go up. There will be no space for the graph to go down. What's next? Identify theta 1. So take your degree scale. This is my degree scale. I'll place my degree scale with the x and the y-axis. Make alignment, okay? And then identify theta 1. What's theta 1? 46. So where is 46 degrees? Here. Put a line where you have 46 degrees. Oh wait, this is 40. See, it's easy to make mistake. 40, 45, 46 is actually here. There, okay? That's 46. It's hard to move with there. That's 46. And 138. So where is 138? This is 130, 140. So 138 is actually here. Okay, maybe that's 137. Yeah, 138. I have to move a little bit to the left. There, 138. Okay. So once you have identified, I hope the eraser is good. Okay. Once you have identified your theta 1 and theta 2, it's time to make the line. 7.5 centi. Okay. Start with your 0 and then rotate your mascara until you reach your angle, 46 degrees. So draw 7.5 centi up to there. Okay, that's your T1. T2, 75 centi. Sorry, 7.5 centi. Okay, so let's move it up. T2, 7.5 centi. So now you have T1 and T2. Now the technique which I showed you was to measure the angle between T1 and T2. But there is another technique. That's why I want to do it in live. There is another technique here, which I want to do it in live. Okay? That's why we repeat everything. What's that technique? By using, excuse me, two rulers or two mascara. The first ruler is usually the degree scale, this one. You want to take the 90 degrees, okay, this line, and you want to place it with your T2. Mustaqim, like this. Can you see? I will place the 90 degrees with T2 so that you will see this is your T1. That's the end of T1. This is your T2. That's the end of T2. Okay? I will take my degree scale and place it with T2 like this. Come on, camera, focus. There, like this. Can you see what I did? You want to align your degree scale with T2. Okay? Shabab, can you see what I did? I think everyone is sleeping now. Hello?
Yes, teacher.
Yes,
Maybe it's time to check the attendance. Come on.
Yes.
I will take
can check.
a second ruler. Okay, good. Please answer. When I say it's clear, you have to answer. I will take a second ruler. You see here? I have a second ruler.
Okay.
And I will place it at the edge of my degree scale. Okay? Can you see? I'm putting them together. What's the purpose? When I slide the setup, this mascara, the degree scale, will reach the end of T1. Where's the end of T1? I'll point to you. There. You see the tip of my mascara? That's the end of T1. Right over there. Okay? See what's going to happen. it's like moving T2 at the end of T1, like this. What's the benefit if I do this? Let me show you the benefit. Without further measurement, I will be able to identify the angle of T2 here from the end of T1. Do you want me to repeat, or did you understand what I did? Let me zoom out.
Can you repeat that?
Yes, I will repeat. It's a drawing technique, Shabab. Okay, it's a drawing technique. First, you have your T1 and T2s, huh? That's your T2.
That's easy, but the last thing.
Yes, I will place the 90 degrees of my degree scale with T2, like this. They should be together, perfect. Okay, that part done. Next, I will take a ruler and place it with my degree scale together. Can you see? I slide it together. But instead of the ruler, I will slide the degree scale, this one. When I slide, it's like I'm moving the line of T2 up to the end of T1. Where's the end of T1? The end of T1 is there. Can you see with the pencil? So I will slide it until it will reach the end of T1, and I will stop. And what does that give me? It gives me the angle of T2. Right here, you can mark it as the angle of T2. What's the purpose? From there, I will simply measure 7.5 centimeters, like this, okay? 7.5 centimeters. So what do I get? You have T1, you have T2. This one here is your T2 prime, okay? So I get T1 and I get T2, and Blackboard went to sleep. 1 second. Let me just minimize and bring it back. Okay, there you go. So now let's zoom in. What to do with this setup? The next thing to do is to measure the length from the tip of T2 prime up to the point of origin using your ruler, your mastera. Okay, let's measure it. Take your mastera from the end of T2 up to the point of origin. How much is that? There, let me fit it. Can you see the reading here? How many centi? Tell me. How many centi is this?
10.3.
Okay, so draw the line. That's correct. And the length of the F-real or the resultant is 10.3 centimeter. And we know that by using the scale, this is 103 grams. And finally, measure the alpha here using a degree scale. Okay. My degree scale is a little bit complicated because it's used in drafting. But don't worry, we can read the angle easily. And the angle is there. This is 40, this is 50. So how much is this? 45, 46. Wait, 45, 46.
Not in the line, exactly.
47. Yeah, 47. Okay, so alpha is 47 degrees. And this is your graphical method. Okay, what I will do, Shabab, is I will take a picture of this and send it to you by Messenger, Telegram, or and Blackboard. Okay, I will post it in Blackboard, but you must submit your own graph. That means you have to make your own graph by hand. Is that clear? Any questions from here?
Yes, teacher, the
So-
alpha. How can we get
Yes.
the alpha?
The answer. Okay.
Not
Good
answer,
question.
the alpha.
The alpha. Okay, I thought you said the answer. How you can get the alpha is simply measure the angle from T1 to R. Okay, so from T1 to R, how do you measure the angle? Use a degree scale. Put 0, x-axis 0 on T1. like this, okay? So this is T1. This is T1. What's the angle of R here? Measure it. That's the alpha, 47 degrees, okay? Any questions? Now, let me show you what to do with this value, okay? 103 and 47 degrees. Go to the lab report, and in the lab report, you have the graphical method. Simply write, oh, wait, let's remove the paper. Simply write in the resultant, where's my pen? There it is. 10.3 centi, 103 gram weight, and what's the angle between them? 47 degrees. That's how you will fill the information regarding the graphical method. Any questions with the graphical method, Shabab? Any questions? The other two will be, trust me, it will be easy, okay? Any questions with the graphical method? Before we continue, because that's it, finished for the graphical method. Guys, questions?
Doctor, if I did the opposite, instead of taking T2 prime, I took T1 prime.
You will get the same result.
So it will be correct.
Yes, but your alpha will be confusing, okay? How to get alpha, Shabab? You have to measure the angle between T1 and the resultant, okay? Again, if you cannot get it, the video will be available in the link in YouTube, and also it will be available in Blackboard, okay? Now let's continue. What's the second method for finding the unknown mass? Okay, the second method is the easiest one. It's called mathematical method. So what I want to do is, first I want to take these values, okay? Let me take a screenshot of these values. Oh, sorry. There, okay? And then I will scroll down to the mathematical method. Excuse me. In the mathematical method, you have to substitute these values using a given equation. There, okay? So you have T1, this is T1, you have T2, this is T2, T1, T2, and then cosine theta. Now, how do you get cosine theta? You have theta 1 and theta 2, but not cosine theta, or not theta. If we go back to the graphical method, and in fact, if we go back to the drawing, we have it actually. Theta is the angle between T1 and T2. That's theta. It's the same angle which we measured here, okay, in the graph. So is there a mathematical way to find the value of theta? Yes, there is. This is the equation to find the value of theta. So you have to minus theta 2 minus theta 1. What is theta 2 and theta 1 again? Theta 2 is 40. Theta 1 is 46. Theta 2 is 138. So let's substitute. 138 minus 46. Yalla, give me the answer. How much is theta? Anyone? Use your calculator. Come on. How much is theta?
92, Mr. Sim.
Okay, if you say so, we will use this value, okay? 92. You said 92. I'll trust you. Next, let's substitute the value for f determined. T1 squared, that means 75 squared, okay? Quantity, or we can remove quantity. Plus 75 squared, that's T2. Plus quantity 2 multiply 75 cosine of 92. This angle is the cosine, okay? I will not give you the answer. Instead, in your report, I want you to calculate this. One thing that's important you have to know, your calculator must be in degree, not in radian. Is that clear? Do you know how to check if your calculator is in degree or in radian? Your scientific calculator, do you know how to check if it's in degree or in radian, Shabab? Can anyone tell me?
It's in the top, Doctor. D, letter D.
Okay, in the top, it should be letter D, not letter R or G. Okay, it should be D. How do you know, or how do you change it? Go to Shift, Setup, and then select degrees or DEG. Clear? If your calculator is in radians, you will not get the correct answer here. Okay? Now let's continue. Once you
Mr.
have...
Fem, is it
Yes, go ahead.
correct that I have a big number?
Okay, you want to tell me the number?
Yes, I got it.
Okay, one thing you should not forget is what? Look at the equation. I didn't mention it, but there should be a big square root. The final answer, there should be a big square root. Look here, square root. Okay? That's why your answer is big.
I took square root.
What's your answer now? It should be 100 something.
104.1.
Okay, that's excellent. 104.1. Remember what we measured in the graphical method? Look, 103. Is it near?
Yes.
Exactly.
1.1.
It's near. Look at the value from the balance, from the digital balance. Where is it? Let me go to the digital balance. What's the value? 105. Okay, so you get good values. Finally, you have to calculate also using the mathematical method alpha. So how do you calculate alpha? Again, substitute the value of, don't forget this one is a square root, okay? Let me write it there so that you'll see it in the record. Substitute the value of theta and T1 and T2. So let's do it. This is tangent raised to -1, that's arctangent, over, multiply. You have T2, that means 75 square, sine of 92 over 75 plus 75 cosine of 92 bracket. What's the final answer here? You will get almost the same as the graph. Okay? Any questions? So the mathematical method is actually very easy. Just substitute in the equation. Any questions, Shabab? Any questions?
No, clear.
No.
Okay, I think it's time that I check the attendance. So the attendance is checked by Blackboard, but I have to make sure that everybody is participating and not going to sleep. I will call your name and your ID number. You have to answer by chat or you have to answer by microphone. What else? There is another way to, what do you call this one? There is another way to take the attendance from everybody. What is that? I can ask a poll question. Okay? What does it mean I can ask a poll question? I would just say a question which everybody has to answer. Like, for example, present or, voila, if you are not present, definitely you will not be able to answer, right? So this time I will check the attendance by name. 698, Muhannad Al-Katani, are you here? Muhannad? 698? Muhannad? Okay, so he's not answering means he's not here. 959, Hamad Al-Otebi. Hamad? Not here. 249, Bader. Bader? Also not here. Did I print the wrong lab? 355, Omar. What section are you guys?
39.
788, Abdulaziz. 788, Abdulaziz. Did I print 39? Let me go to EduGate quickly. Password, SMS 329. Report, instructor report. Again, 39. And complete weekly attendance, week 2. Print. Let's see. Salam. Yeah, I printed the wrong attendance. My mistake. That's why everyone is absent, huh? Okay. Yalla. 235, Salman. 235, Salman, are you present? Salman Al-Katani.
Yes, yes,
235.
Doctor.
Okay, good. 319, Fahad. Fahad, 319. Shabab, you know if you are coming next, so you should answer. 319, Fahad Al-Ajmi. I can see you are connected, but you are not answering. Fahad Al-Ajmi. 763, Rayan. 763, Rayan. Rayan Al-Malki. 943, Waysam.
Yes.
Waysam? Good.
Yes.
060, Ali Al-Shakak. Ali. 060, Ali. Oh my God, you are connected, but you're not answering. Ash, what happened? 263, Soccer.
Yes, yes.
263? Okay, Soccer is here and Ali is answering by chatting. Good. Come on, guys. 270, Turkey. 270, Turkey. I don't see any Turkey here. Okay, so Turkey is absent. 312, Hassan. Hassan Al-Ghazwi. Excellent. 703, Abdulaziz.
Yes, I'm here.
Excellent. 744, Muhammad Al-Dosari. Muhammad Al-Dosari, 704. 744, sorry. 744, Muhammad Al-Dosari. Okay. 766, Ahmed. 766, Ahmed. Excellent.
Yes, yes.
928, Salem. 928, Salem. Excellent. 067, Saeed. Saeed Al-Ghamdi.
Yes, yes,
067.
yes, I'm here.
There you go. 711, Saud Al-Khaldi. Saud? Saud Al-Khaldi just joined the session. Okay. Can you hear me, Saud? He raised his hand. Fine. 152, Abdul Latif. Abdul Latif? Okay. Saud, maybe your brother raised your hand. 314, Muhammad Al-Hussein. Muhammad Al-Hussein, your signal is bad. I hope you can hear me. Muhammad. Okay, those who are not present now, I will check again to make sure that you are here, okay? I don't want anyone absent. The last part, Shabab, let's continue. Saud Al-Khaldi, you have problem in Blackboard? What's the problem? The problem is not Blackboard. The problem is your internet. I made you present anyway. I saw you. So the last method is called Analytical Method. And once we finish this one, that's it. We are done with the experiment number 3, okay? But I want you to know one thing, that this method is not in the final exam. Clear? The last two methods, the first two, sorry, Hadi, mathematical, graphical method, will be in the final exam, okay? So the last method will not be in the final exam, but it's important for you to learn how to do the analytical method. Now let's input the data first. We know that T1 and T2 are, what happened? Again, let me use my pen, it's easier. Where's my pen? We know that T1 and T2 are 75 and 75 gram weight. This is 46 degrees and this is 138. To get the x component of T1, we use T cosine theta. Okay, so how do we substitute the value there? 75 cosine theta 1, 46. What about Ty, y component? That means the experiment is with us. In the final exam, yes. Okay, this is 75 sine 46. We use the angle theta 1, because we are talking about T1, okay? And this is the X component and Y component of T1. What about the X and the Y component of T2? Substitute 75 cosine 138 and 75 sine 138. What you will get, Shabab, is the total in the X component or X-axis and the total components in the Y-axis, okay? The result from here and here, you will substitute. The result from here and here, you will substitute. Is that clear? From there, you will find the resultant in the X-axis, the resultant in the Y-axis. You will use those two values to substitute and find the determined value for the unknown mass using this equation. Is that clear? How you will complete this table? Is it clear? Because you don't have to complete it now. I will not answer it for you. I want you to calculate. Okay.
Yeah.
Now, you have to notice something which I will give you as a clue. Okay? What is that? The value here on the X-axis is almost or near 0. The total value in the X-axis is almost 0. Why? If we look at the direction of the unknown mass, okay, you have here T1, you have here T2. The unknown mass is actually hanging in the center, okay? This is your FR. 1 second. This is your FR. Look at the direction of FR, downwards. Downwards means 270 degrees. What is the X component of 270 degrees? In this case, it's actually 0. Clear? But by calculation, you will get almost 0. Why is that? If we look at the graph that we did, let's look at the graph that we did, okay? You will see that the resultant is not exactly on the y-axis. If everything is perfect without friction, you will find that the resultant is on the y-axis. And in some cases, you will get the resultant exactly in the y-axis by graph. In some cases, okay? Can you see here? This is R. It's not exactly on the y-axis, okay? In some cases, you will find it exactly in the y-axis. Why is this? Because there's a third source of error. What's the third source of error? Let's go back to our setup. The third source of error is that in this pulley, pulley 1 and pulley 2, there is friction, okay? So that because of the friction, the position of the angles and the string will not be the same all the time if you use the same mass. There is a chance that these angles will change by a small number. That's because of the friction on the pulley, okay? That's why in your lab report, at the end, you will write the source of error and the precaution. What's the source of error here? You can write there is friction in the system, or you can say there is friction in the pulleys. What's the precaution? So if you have this type of source of error, you can type or you can write a precaution. This is number 3, okay? So what's the precaution? That means how you fix or prevent it. You can reduce the friction by using lubricant. Just like in an engine. To reduce the friction, you have to use a lubricant, an oil, okay? So this is the reason why this is not exactly 0, but almost 0, okay? So what I want you to do is to calculate this, find the F determined using this equation, and then finally find the alpha. So I'm going to explain to you finally how to find the alpha, okay? Because finding the alpha is more complicated. It requires a condition. Let's talk about finding the alpha. First, before you find the alpha, you must find what we call the phi, okay? This symbol is theta, Greek letter. This symbol, if the line is vertical or diagonal, is called phi. Okay? They are different. They're not the same. So first, you must find the value of phi. How? You get Rx and Ry, this table, that's your Ry and that's your Rx, and substitute here and substitute here. Okay, Ry and Rx. Once you have substitute Ry and Rx, what are you going to do? You will get the value of phi in degrees. What is phi in our graph anyway? Let's go back to the graph. Where's my graph? 1 second. There it is. Okay. This is like the graph that we have. Remember that we have alpha. Let me show you alpha. This is alpha. Let me show you phi. This is phi. The angle from x-axis going to your resultant. The difference, alpha, the angle from T1 going to the resultant. So alpha is from T1 to resultant. Phi is from x-axis to the resultant. That's the difference, okay? So let's go back to our calculations. Calculations, here. How do you find the alpha once you have the phi? This is the condition, Shabab. You will choose only one of these two choices. Why not? The highlight is not working. Never mind. I'll just circle it. If the angle phi is positive, which angle? The answer here is positive. You will take this equation. Alpha is equal to phi minus theta 1. If the angle is negative, okay, which angle is negative? This one. You will take this equation. That means to find the angle alpha, you have to check the condition of phi. In the graph, you will actually know if phi is positive or negative. Let me show you how. This is T1. This is T2. And this is our T2 prime. And this is our R. And I'm making exaggeration, okay? That's the y-axis. And this is the x-axis. If your R is on the left side of the y-axis, which quadrant is this, Shabab? Can you tell me which quadrant? 1 or 2?
Negative.
This is yes, this is quadrant 2, so your phi is negative. But if your R is on the right side, your phi is positive.
Positive.
Clear?
Yes.
That's the idea about phi, okay? If you can calculate, you will simply see it here if it's positive or negative. That means you will use only, if your phi is negative, you will forget about this one. And you will use only this equation. Is that clear, Shabab? Once you do all the calculations, I want you to go down to the result. This is a summary of the result for the experiment. Number 1, according to the graph, our F determined is 10.3. That means 103 grams. According to the mathematical equation, somebody calculated. He said 104.10. According to the analytical equation, okay, what's the analytical equation? Here, F determined. What's the result? You have to write it here. Once that's finished, what's the alpha in the graph? 47 degrees. What's the alpha in method 2? Let's go back to method 2. This is the alpha for method 2. That's the equation, okay? What's the result? For example, we calculate maybe 47 or 46. Just write it there as an example, okay? What about the alpha here? What's the result? You write it here. Clear? Once you finish summarizing the result, we will go to percentage error. Percentage error is a comparison of the real value of any measurement as opposed to the determined value using the experiment. The real value in this case is by balance. I gave it to you. this is 105, absolute, minus the determined value by graph, 103, over the real value, 105. So this is the real, this is the real, and this is the determined value. Okay? But you have to remember that this value is absolute. What does it mean, absolute? That whenever you get a positive,
always positive.
okay, positive or negative value, the result that you will take is always positive. Okay, absolute value. Multiply this by 100%. That will give you a percentage error. Let's try it. I will use a simple calculator. Okay, so I can show you the percentage error. Oh, I have a scientific one, see? So let's try it. Do I have fraction here? Honestly, I don't know how to use the scientific here in the computer. So I'll just take it as normal. 105 minus 103, absolute value, okay? Divide by 105, real value. The answer multiplied by 100%. So I get a percentage error of, what's the percentage error? 1.9%. 1.9%. This is how you finish your lab report with the percentage error. And you have to do it 3 times. The first time using method 1. What's method 1? By graph. Clear? What's method 2, Shabab? By mathematical equation. What's method 3? By analytical method. Analytical method. Okay? Finally, the source of error and precaution. We already discussed it. How do you write source of error and precaution? If you have a source of error, source of friction, precaution means how to fix it. If you have precaution, the string must go over the pulley. How do you write the source of error? The opposite. Okay, what's the source of error here? The string is not on the pulley. What's the effect if the string is not on the pulley? The mass will not pull correctly. Okay, what else? The masses must be steady. How do you write it as a source of error? The masses are moving, or you can say swinging. What does it mean, swinging? Let me show you in the video. Look at the beginning. Mass and find objects mass 70 over teacher for some assistance. Okay. Once you hang, look at the masses. They're moving. Make sure that it's not touching the table. If it is, so this masses should not be moving. What's the reason? If they are moving, the angles here, you will not read it correctly. Clear? What else is a source of error? I didn't write it, but we discussed it here. Okay. Number 1, let me go back to the video. Number 1, where the strings will meet, where the strings are tied together. Okay, we call it junction of the strings. Should be in the center of the degree scale. That's a precaution. If this string is not in the center of the degree scale, what's the problem? Your theta 1 and theta 2 will be wrong. What else? The string of unknown mass, or you can say the string of F real, must be at 270 degrees. If not, again, your angle theta 1 and theta 2 is going to be wrong. Okay? You will actually see the source of error and precaution in your book. But I have to tell you a simple warning. Not all the precautions in the book is correct. Sometimes it is mistake. Okay? So we modify the lab manual to make the improvement. What are the mistakes? Number 1, the grammar is wrong. Number 2, you can also say that the physics is wrong. Look at number 1 here. There must not be any friction in the pulleys. This one is wrong. Why? Is it possible to remove friction? Shabab, can you answer me now? Especially from mechanical. You should know this. Is it possible to remove the friction of any system?
No.
It's impossible. So to write this statement is actually a mistake. How should you write this one correctly? How should you write this one correctly? As a precaution, reduce the friction. You cannot make it 0, you can reduce it. Okay? What else? Thread must be on pulley wheels. This one is, the grammar is wrong. So we want to write the grammar correctly. just say the thread must be on the pulley. Done. Okay, it's the same as the source of error and precaution which I gave you at the end, right there. Now, questions. When do you submit this report? Next week when you go to the lab. That's question number 1. Question number 2, do we have Group A and Group B in the lab next week? Yes, we will have Group A and Group B in the lab next week. You will get Group A and Group B in Blackboard as well as in the not private message, in the group message. Okay? Any other questions? Any other questions? Yalla, if you have questions, tell me now.
Mr. Tim, the math work we do in lab manual, it's for us, but the data sheet, it's for you, right?
Yes. You will submit to me the data sheet next week. Okay?
Okay.
Okay, let me give you, I will stop the recording now, okay? Because we don't need to record everything else.